Yeah, good evening, everyone. So, Johnny, hands. Let's start off. Hands on, everyone. Why so many people are missing today? Let's see. I am at my hometown now, so there is a net issue a bit. Here are the others, right? Gods, people will miss introduction. Okay, let's start off. So we'll be starting off. Last time we finished off with siphon, right? Fluid mechanics. Yes. So what we will do now, we will start with electrostatics, and then we'll go for gravitation, and then we'll go for viscosity and surface tension. We'll go in that order. Reason being, we could have done gravitation, but then the gravitation, right, has only all attractions only. So in electrostatics, we have attraction and repulsion. So if your electro is good, Gravica, at least the starting, 70-80% will be quite easy to handle. Right. So let's do electrostatics and then we'll go back to Gravi again. Yeah, let's start it off. Others, do keep your cams on. So this entire electromagnetism, right, is roughly a weightage of 33% in entrance. So what is this electrostatics? It deals with interaction between charges. A little bit of theory. At rest or slow moving charges. So we want the charges to move relatively slower, right? And or at rest. Reason, whenever the charges start going at pretty high speeds, things get messed up. They also generate something called magnetic fields. And relativity effects come into picture. So we will not deal with them. So what is this magnetism and all? We will see later on in a separate chapter. So primarily, right, charges are of two types. Now, why two types? People classified that way. Whenever people were doing a lot of experiments, they found out there are only two types of charges there. They simply call them, one is positive charge and one is a negative charge. You could have even called it A and B also, but fine. So example of a positive charge is a proton. Example of a negative charge is an electron. Now, why electron is a negative charge? Someone just named it. There is no logic behind it. Ideally speaking, if electron had been positive, your life would have been easy. Because if you see the definition of current, the flow of positive charge is called current. So initially people thought, right, the positive charge ka flow is called current, but someone named electron is negative. So when electrons are actually going this way, the current is actually going in the opposite direction. It is a little messed up. So what is the problem now? Why can't we change it? Because you have already printed all the books. So to change the printing in all the books, it is expensive. It looks very silly, but if you think about it, right, just imagine, okay, from your year, it is changed that electron is positive and proton is negative. It will be a mess. For 1-2 years, people will be getting confused. Everything will be a mess. So people said, yeah, let it be. It doesn't matter. So the charge of a proton, we take it as 1.6 into 10 power minus 19 coulombs. Basic stuff. You know this from chemistry. I'll just brush through up. So here, the sign indicates both are of opposite nature. Others need to keep your cam on, or else I'll be removing you from the classroom. You can note down the important points if you want. I'll be sending the PDF anyway. Right? So if someone asks you like this, the 5 coulombs is greater than minus 5 coulombs. or minus 3 coulombs. This does not make sense. You can't say plus 5 coulombs is greater than minus 3 coulombs. It doesn't make sense. You can't compare like that. The plus and minus simply indicate one is both are of different types of charges. Okay, so don't take these signs literally. Clear with this? Then, any doubts on this page? Basic introduction, there's nothing there on this. Properties of charge. So in an isolated system, charge is conserved. Meaning, if you have a body like this, and let's say if it has minus 5 electrons and 10 protons, let's say electrons combined with protons, and let's say you have 3 electrons, let's say minus 2 electrons, 3 neutrons, and 7 protons. So if you observe here, the charge, total charge remains same. The number of charged particles change. So initially you have 15 charged particles, 10 protons and 5 electrons. Now we have only 7 plus 2, 9 charged particles. But the total charge initially it is 10 minus 5 and finally it is 7 minus 2. But the total charge remains same. Next thing, charge is quantized. What do you mean by quantization? You heard this first time where in chemistry, remember? Angular momentum is quantized. MVR is equal to NH by 2 pi. What do you mean by that?
Turn into a number?
1, 2, 3.
So basically, whenever you say it is quantized, any charge transfer rate is an integral multiple of a certain quantity. I'll give an example. That is, if you say I'm giving charge Q to the body, you can be sure it will be n into E, where n is an integer. Now, what is the meaning of this, right? See, for example, right now, the minimum denomination that you have is 50 paise. That means whatever money that I give you, right, should be in terms of 50 paise. I can't give you 2 rupees 83 paise, isn't it? I can give you 113 rupees 50 paise. I can give you 237.550 paise. I can never give you something like 23.27 rupees. So the meaning of quantization is any transfer or anything that happens will be always an integral multiple of a certain fixed value. So in this case, that certain fixed value is an electron charge. So you can't transfer something like an half electron charge, 1/4 electron charge, you can't transfer. So that is the meaning of quantization. Rhythm, come on. Dipanshu, Hamu, Camson. Do have a look at that. Clear with that? Any doubts on this page? Then this is standard. Like charges repel, unlike charges attract. Whenever charge transfers, right, it is because of free electron transfers. Free electrons are responsible for charge transfers. What do you mean by free electrons? These are the electrons, right, which are roaming freely in the lattice. They are not bounded to the nucleus. You must have heard this thing in conductors have a lot of free electrons. Insulators have no free electrons. So whenever you say a body is having a positive charge, the meaning is it doesn't mean it gained extra positive charge. Someone removed electrons. So lack of electrons, we call it as a positive charge. When you say body has a negative charge, means it has excess electrons. So never think a positive charge body has extra protons. Getting it? So whenever you say a body is positive charge, means it is actually having a lack of electrons. It doesn't mean it has extra protons. Charge is independent of velocity. No matter how fast you go, the charge will never change. Looks kind of obvious, but it is not, because mass changes. If you see, mass of a body is actually given by m naught by root over 1 minus v square by c square, relativity. This is called rest mass. So whenever you actually increase the speed of a body, mass changes. C is the speed of light. So when the mass of the body tends towards the speed of light, mass becomes infinity. So this is basically the relativistic effects. So mass changes with speed. So that point actually makes sense now. Generally, people think what charge is independent of velocity. Isn't it obvious? It looks obvious, but mass actually changes with velocity. So it is not obvious. Have a look at this point. Yeah, the faster you go, more mass you have. But if you see in this denominator, c is 3 into 10 power 8. So even if you go at a speed of 1000 kilometers per hour, it really won't make much difference. We are talking about speeds comparable to speed of light. Then you will see a huge difference. Have a look at this page. All clear with this? Any doubts on this page, please ask me. Labdi, Danya, clear now? Gauri, Anamai, clear? Next thing. Great. So how can you create a charge on a system? There are three ways to create a charge on a system. We are not creating charge, we are creating charge on a system. So first one is by friction. So if you take two bodies and if you rub against each other, electrons are transferred from one body to another. So let's say you take a body here, body here. So this has electrons. This also has electrons. And if you rub them, let's say mass is m and mass is m. Initially, both are neutral. So after rubbing, what happens? Electrons, right, will transfer from one guy to another. It can be anything. This becomes positive charge. This becomes negative charge. Total charge will be 0. Huh? Total charge is 0 because overall was neutral. Now, if I ask a question like this, if two bodies are, two identical bodies are neutral, identical bodies are rubbed against each other. After rubbing, who will have more mass? The positive charge or the negative charge?
Negative.
Who has
charge.
more mass? The negative charge, no? Because it gained electron. So this guy will be m minus delta m. This will be m plus delta m. It is very small, but yeah, there will be a small change in mass. So this is the first thing. So if you rub against something, right? In school, you must have done this, right? You take a comb, comb your hair and put near the paper. Paper pieces attract. Ever done that? So how does that comb become charged? It is because of by friction. So whenever you rub two surfaces against each other, right? This is what happens. Clear? Second, by conduction. So whenever you connect two conductors, right, the charges will start transferring. When two conductors are brought in contact, charges transfer till the potential becomes same. What is this potential? We'll see later on in more detail. So that means if you take two bodies here identical, let's say this guy is 2q and this guy is minus q. And if you have a switch, these are identical conducting shells. The moment you close the switch now, because both are identical, what is the total charge? Q. So this will have q by 2 and this will have q by 2. Is that making sense? Because both are identical, they should have equal charge. And this is 2q and minus q. So total charge is q. So both will share half and half, q by 2, q by 2. Because they're identical. If they're not identical, we have to use a different formula. We will see that later on. This is the second method. You can take a charged body and you can touch it and you can transfer charge from one point to another. The first is friction, second is conduction.
So charge will flow from like right to left, right?
Left to right, no? They'll go from positive charge will go, meaning indirectly electrons will go from this way, so positive charge goes this way.
Okay, sir.
Technically speaking, it is always the electrons which will move, but we talk as if the positive charge is going. Okay. All clear with this? Third, by induction. So when a charge is placed in front of a material, it induces charge. What do you mean by this induction exactly? See what happens. Let's say we have a body like this and you put a positive charge in front of it. So what will happen? The electrons inside will get attracted, right? So if you took an electrons here, these electrons are attracted by this positive charge. So because of this, you will observe this entire side becomes negative charge. Because this became negative, this becomes plus. So you will induce some charge minus q and plus q. Think of like this. Let's say we all are sitting in a classroom. I bring a box of chocolates and keep it there. What will happen? people will start jumping right towards the chocolates. So all the seats at the back bench will become empty, na? So the vacancy of electrons is a positive charge. So positive charge doesn't mean, there's a proton there, excess protons. It is actually a vacancy of electrons, lack of electrons. And all the people have come front, right? So they got accumulated. Yeah, it's like polarization in chemistry. Making sense? And both of them should be equal because initially this was neutral. Right? And something interesting happens. If you look at this plus Q and minus Q, they're more closer compared to plus Q and plus Q. So what will happen? The bodies attract now. So even if you put a charge in front of a neutral body, it attracts. Attracts since the opposite charges are closer compared to the like charges. You could have done this with a other charge also. Let's say you have a minus Q charge. Now what happens? The electrons actually get repelled. Think of like this. We all are in a class. I take a stick and start beating the people in the first bench. What will happen? Everyone will try to run away to the back benches, right? The front seats will become empty. What, every time you want to eat chocolates only, yeah? Sometimes you get beatings also. So in this case, what would happen? This would be minus Q. So this guy will be plus and this guy will be minus. So this will be plus Q, this is the minus Q. Now something interesting, this also attracts. Because still minus plus is closer than minus minus. So if you put a charge in front of a neutral body, you'll always attract. It doesn't matter whether you keep a plus charge or a minus charge. Have a look at this. This is conduction. So these are the three ways you can.
So for in the second one, but you had said like the plus charge is there because the electron is not there. It doesn't mean the proton is there, no?
No, meaning
So
actually, yeah, protons are there, but they're not excess protons.
Okay.
Initially, imagine you're taking something like sodium. It has 11 protons and 11 electrons, right? You remove the electron in the outermost shell and remove there. So there are 11 protons and 10 electrons. So there's a vacancy. The shortage of electrons is called as positive charge. It gives you a feeling you have one extra proton, but in reality, the proton was always there, electron went away. That is what I mean to say. Protons will never move.
Okay, sir.
All clear with this? Middle part remains same. What do you mean by that, Ratan?
That means the middle part remains same as if it were in neutral only. So like only the endpoints change.
You're asking about this point here.
Yeah.
If it is a conductor, this is how it looks. But if it's a insulator, you can have charges here also. They'll actually form dipoles. We will do that in later on. We'll not get into that right now. Okay? But what you're saying is true. For insulators, actually charge will be there in the middle also.
Okay.
So now let me show you something and I'll ask you a few questions. So let's see on that. So see, so she's going to do something. Then I'll ask you like, see, we have three processes. What is that? One is by friction, by conduction, by induction. So you have to tell me what happened exactly there. So we have two styrofoam plates. You must be seeing these food cup plates and a cloth. Did you see what happened? You rubbed one plate and you kept it on the other plate and see what is happening there. Look at that again. Two plates. You rubbed one. Then you touched the other one. And then you left it. It repelled. What's happening here?
Sir, due to friction, there is charge.
Okay.
And like charges.
Like charges repel them.
Like charges.
First you do friction and then
So-
you do induction.
induction नहीं है. First is friction, right? Because you're rubbing it. Second, you're touching them, na? When you made them both touch each other, the charge got transferred between them. And both became like charges. Isn't it? That's where they're repelling. See, initially when she kept it in the beginning, na, this is by friction. Now see, when she's bringing, there is no repulsion here. It is just coming normally because the upper plate is neutral. The bottom plate is some charged. Now when you touch them, the charge gets transferred between both of them. Now both become equally like charged. Both can be negative, both can be positive. We don't know that, but both are like charges. That's where the repel. Getting it? So here we have friction and conduction. There is no induction here. What is this?
First friction, then induction.
Narayana, now you are right, will this be? So you're not touching this thing, right? So first initially it is friction, then the charge is induced on the metal container and you are getting attracted. So first it is friction and then induction.
Just in this case, the can is neutral.
Come again?
In
Can
this
is
case,
neutral.
the can was
Can is
neutral.
neutral. This is dosa. You can attract even soap bubbles also.
Induction.
Friction and induction, na?
Yes.
Yeah. You can even bend the water also. So that's what I said, you need not have a conductor. You can induce charges even on an insulator. If you can see here, the water is also bending. Because you're inducing charges on the water stream, they're getting attracted. Actually, this is the electroscope is the experiment, how people figured out about the charges and stuff. I'll show you how this works, but see what they did. So what is happening, right? Niche, you have two aluminum ka thin wafer kind of things. On the top, you have this. So initially, there's no charge between them. So that's why they're touching each other. So you rub this. Once you keep it there, can you see how they're repelling each other? So they'll start moving around. So how is that electroscope working there? So electroscope, what is happening, right? Let's say this is the container there. So this is the rod. You have this, you take something thin. Now see what is happening. Let's say if you bring a positive charge, what will happen? This will become negative. Because this becomes negative, this has to become positive, this has to become positive, no? This will induce minus Q charge, and yeah, this is a gold leaf thing. So this will become plus Q by 2 and plus Q by 2. Is that making sense? The other side will get a positive charge, and that's why they're repelling. Basically, this is a gold leaf electroscope experiment. Why do we use gold?
A
Because
lot
we
of
are
free
rich.
electrons.
Better,
नहीं
better,
Ionization energy is less.
ना रे हाँ रे ना
better conductor.
बेटा कंडक्टर ना. Anyway, do you guys remember this Rutherford gold foil experiment?
So it is very thin.
Yes,
Why did Rutherford use gold? Someone said he's rich.
Sir, very thin.
Because gold, right, has a property. You can make it into very thin sheets. You can make a thickness of atomic layer. Because think about it, in Rutherford gold foil experiment, if you use a thick layer, when the protons are going inside, if alpha particles are going inside, agreed, it will have a lot of spaces. But if you are very thick, the alpha particles will collide, right? So you made it so thin, most of them just pass through it. So gold has that property, it is very malleable. You can make it into very thin sheets of molecular level thickness. That's why we use gold, not because Rutherford is rich. That was not a bad reason. I was teaching in the medical batch. I asked them the same question. Why did you use gold? Someone said, sir, Rutherford must be rich. Okay, yaar, people are interesting. People have different weird answers. Okay, so this is clear. So let's see a question and then we will go for a little more theory. Let's say we have 4 bodies here, A, B, C, and D. A is positive, given. A and B repel each other. B and C attract. C and D attract. B and D also attract. What are the charges on BCD? Find charges on BCD. Let's get this. Easy one.
Sir, positive on B, C is negative, D is negative.
Which is a negative?
C and D.
But C and
But
D are
then how will
attracting.
they attract then?
Or if B and D positive, so they don't attract.
Sir, D wala is no problem.
Is it possible that none of the BCD are charged?
But A and B are repelling. C is negative.
I think B is negative and D is positive. C is neutral.
But
Then
then
how?
A
It is
and
a
B
positive.
repel.
That is a possibility
Yeah.
which you guys didn't think of. सबको वही लगता है, no? They should have some charge. Not necessary. You can be neutral also, no? You'll attract when you're neutral. So one thing is clear. See, A is positive. A and B repel. So definitely B is positive. Itna clear hai? Now C can be negative and D can be neutral. Because a neutral body will always attract, whether you keep positive or negative. Or there are 2 answers for this. A is positive, B is positive, C is neutral, and D is negative. Make sense? Now see, B and C will attract, C and D will attract, B and D also will attract. One of them is neutral. But the general tendency we have is we think only in terms of positive and negative. We can also have a neutral body. Easy? Great. Next
Sir,
one.
neutral will always attract.
Neutral will always attract ना, अभी तो किया था.
Okay.
Because neutral body, what will happen? You'll always create an opposite charge which is closer, isn't it?
Yes.
You always attract. All clear with this? Any doubts on the question? Easy one. Next thing, Coulomb's law. So if you have 2 charges, Q1, Q2, with the distance r between them, So this will experience a force F21, meaning this is force on 2 due to charge 1. And this force will be F12, force on 1 due to charge 2. So what Coulomb's law says is, force between the charges is proportional to the product of the charges and inversely proportional to square of the distance between them. Here we have to add a small thing actually. Listen to this carefully. Books mein what I'm teaching now, this part is missing. But you do get questions on this in vacuum. This word is important. We will discuss about that in detail. So here F12 is equal to minus F21 Newton's third law. Forces are equal and opposite. And this magnitude F is given by 1 by 4 pi epsilon Q1 Q2 by R square. This we will write it as K Q1 Q2 by R square. So this K is nothing but 1 by 4 pi epsilon, whose value is 9 into 10 power 9. This epsilon is called electric permittivity. Of vacuum. We will discuss about this in detail in the next page, whose value is 8.85 into 10 power minus 12. Have a look at this. If we write this in the vector form, let's say this is Q1, this is Q2. So force on this will be F21. That's the force on 2 due to one charge will be K Q1 Q2 by R square, and the vector will be R12 ka unit vector. This vector is R12 people, meaning vector is going from 1 to 2. Suppose we want the force on this guy, F12. So force on 1, 2 will be K Q1 Q2 by R square. This is the magnitude. The vector is R21 ka unit vector. This is a vector from R2 to 1. This is the vector form. Obviously, R12 and R21 are opposite to each other. Have a look at this. Maybe I'll draw another diagram for you. This is a vector going from 2 to 1. And this force will be F12, force on 1 due to 2. So don't try to think in terms of mathematics, just keep it simple. So if the Q1, Q2 are positive, meaning there's a repulsion force, it's away from the charges. If the force magnitude is negative, if force is negative, it means force is attractive. Getting it? So if someone says the force is minus 5 newtons and force is plus 5 newtons, it doesn't mean plus 5 is greater than minus 5. Minus means attractive force. If force is positive, means it's a repulsion force. Clear? Let's see a question on this. We have a charge plus q is at origin, is at, let's say, 1 comma minus 1 comma 2, and charge minus 3q is at 3 comma minus 4 comma 5. Find force on minus 3q charge. Get this? I want the vector form of magnitude and the vector.
Sir, can you show the previous slide once? Sir, but in this F12 was negative of F12, no, but both were repulsive forces.
So these two will be negative of each other, no?
Okay.
R1 to R21 see na opposite vectors God.
Yes.
Q ka value is 1 microcoulomb. I'll write it down directly. ठीक है. So Q ka value is 1 microcoulomb, meaning 10 power minus 6 coulomb. That is the meaning of micro. Get this? Abhiksha, Rhythm, cams on. Get this one, everyone. Just a vectors, nothing there. What is the force ka magnitude? K, Q1, Q2 by R. What is K ka value? 9 into 10 power 9. You can write down this in case you don't, if you have not written it down. So one charge is at 1 comma minus 1 comma 2. Another guy is at 3 comma minus 4 comma 5. Find the force on the minus 3q charge, magnitude and the vector. I cap, J cap, K cap. Try.
So can you go to that slide where the value of K was? Yes.
K is 9 into 10 power 9. Try. Everyone should give it a try. Give you a minute. Just give it a try. I'll get some water and come. Yeah, any answers? Yeah. So you see, first thing you need to get the one charge is at Q. This guy is at minus 3Q. So this is 1 comma minus 1 comma 2. And this is 3 comma minus 4 comma 5. So you want a vector. How is the force now? It's an attractive force. So we want a vector from here to here. This is your R bar. So what is R bar? Final minus initial, right? So 1 minus 3. Isn't that how we find a vector A bar? B minus A. So R bar will be 1 minus 3 minus 2I cap minus 1 minus of minus 4. So that is the 4 minus 1, 3J cap. 2 minus 5 minus 3K cap. Check. Because it's an attractive force, the force should be towards plus Q. So the vector should go from minus 3Q to plus Q. What is the magnitude of R? 2 square, 3 square, 3 square, 9, 9, 18, root 22. That is your distance between them. So what is R cap? R cap is minus 2y plus 3j minus 3k by root 22. You're done. So what is the force? K Q1 Q2 by R square into R cap. So K is 9 into 10 power 9. Q1 is 10 power minus 6. Q2 is 10 power 3 into 10 power 6. Now don't take minus sign. Huh? The minus sign is already included in the diagram. Isn't that the reason why you showed this thing? So what you want is only the magnitude here. I hope you're getting that. Why it is 3j minus 1 minus of minus 4, na? I hope everyone is getting this. You should take only the magnitudes. The reason, the direction is already taken care of by the in the diagram I showed the arrow, right? So the sign is already taken care of. And what is R square? 22 into R cap. How much is this? 10 power minus 6, 10 power minus 6, 9 threes. 27 by 22 into 10 power minus 3. R cap will be minus 2I plus 3j minus 3k by root 22 newtons. Check. Other than k, q1, q2 by r square, everything is vectors there. Check it out. So if there is a force, entire loss of motion will come. You can bring your entire mechanics. Any doubts on this? Please ask me. Clear? Next one. There is still some theory, but let's do a few problems before going to theory. Theory will be too boring. We already did a lot of theory, charges, and all that stuff. Let's see one more question. Can I turn the page? Any doubts on this? Anyone not clear or not convinced with this? Please ask. Great. So let's say we have an incline, theta, friction, mu. We have a block here, mass m with a charge q. We have another charge q here, plus q fixed. The distance between them is x. Okay, and mu is less than tan theta. So the block can actually slip. Find x if the block is in equilibrium. Block ka charge is plus q. The point charge ka charge is also plus q. So two identical charges, but it has a mass m and the block can slide on this rough surface. Find x if the block is in equilibrium. Get it? Coulomb's law, Newton's laws of motion. How do you do this? What is the catch?
Sir,
Hmm.
sir, under root k q square upon mu g cos theta minus mg sin.
Nah. How many answers are there? Anyone? Whenever you hear the word equilibrium and friction, it's a range. You know where you have seen this question?
Slipping up or slipping down, like it.
Remember this question, maximum, minimum? So what is happening, see, there are two possibilities here. You kept the block so close, so this will be x minimum. So what will happen here? The repulsion is so strong. How will the friction be? Backward, no? And mg sin theta will be backward anyways. So in this case, the repulsion will be how much? K q square by x minimum square. So we get kq square by x minimum square will be mg sin theta plus maximum friction will be mu mg cos theta. This will give you x minimum. So you can't keep anything closer than this. The block will get repelled. Second case, let's say you kept the block so far. Now what will happen? The repulsion is weak. Kq square by x max square. How will the friction be now?
Or downward.
Upward.
Yes.
Record.
Also
And mg sin theta. So because the block is trying to slide downward now. So in this case, it will be kq square by x max square will be mg sin theta minus mu mg cos theta. This will give you x max. So your answer will be anything between x max to x minimum. You can keep it anywhere in the middle. The block will be in equilibrium because friction is the self-adjusting force. It need not give maximum every time. Are you getting this? You can have a value anything from mu mg cos theta in the upward direction to minus mu mg cos theta in the downward direction. You won't get a single answer. You get a range of answers. So x can be anywhere between these two positions for equilibrium. Check. This was the same similar question which we have seen in friction. There I asked you mass of the block for equilibrium. Check. Any doubts on this? All clear with this? Turn the page. Next one. We have a plus Q charge. We have a plus Q charge. Both are fixed. Exactly in the center, you have a charge minus Q and mass M at a distance x. This is d by 2 and this is d by 2. What will happen?
SHM.
SHM.
Oscillate karega na? Find the time period for small oscillations. X is very small. This is free to move. So you took a minus Q charge at the perpendicular bisector, you displaced it. Of negative charge displaced along perpendicular bisector. X is much less than D. Get it? Told you, if I can say there is a force, your entire mechanics will come. How to do SHM if you remember? When you displace by X, find the restoring force on it. Force is equal to mass into acceleration. A is proportional to x. That constant is omega square. Time period is 2 by omega. That is the same story every time. Previous page here. In case you're noting down something important, stop me, because I thought you guys had done and I go ahead. Because anyway, I'll be sending the PDF. So, but Firbi, if you're writing down, let me know. Let's get this thing. Let's spend more time on solving. How do you do this? Try. I'll give you a minute.
So the forces, the electrostatic force won't get cancelled out.
How will they cancel out? Record angle pe hoga na ye. This is attracting like this. This is attracting like this.
Okay.
When you are in the center, cancel hoga na, but that's the mean position, right? So it will have maximum speed. So it will go this side. Then it will attract this way. It will attract this way. It will never stop only, na. When the force gets cancelled, you have gained maximum speed. Show you. So plus q, and let's say this is minus q, and this is x. So this force will be towards this guy. Let it be F, and let this be theta. Let this be force F and theta. This distance is d by 2. So let's call this distance small r. So small r will be root over x square plus d square by 4. So force ka value will be how much? K q small q by r square. See, don't put minus n in this again. The moment you draw the diagram, you are showing the arrow this way because it is attraction. It is attractive. So the sign is already taken care of. What you want is only magnitude. I hope that is clear, because people ask lecture, why are you not taking minus here? What is the meaning of minus n? They're attracting. That is the reason you draw the force towards plus q. If it was repulsion, I would have drawn this way, right? So the minus sign is always taken care of when you draw a free body diagram. You're done. So what is the restoring force? 2f cos theta na? Is equal to mass into acceleration. So F will be K Q Q R square cos theta is how much? X by R is MA. So 2kq x by r cube. That would be x square plus d square by 4 whole to the power of 3 by 2. Since you said x is very small, you can neglect it. Since x is much smaller than d. See, don't neglect this guy. Huh? If you have 0.01 by 20 plus 0.01, you neglect 0.01 with respect to 20. You don't neglect everything and say 0. Be careful. You are neglecting x because you are adding a very big number, so you're neglecting it. Just put a minus sign because we always take the acceleration in the direction of x. Because we choose acceleration in this direction. That is a convention. In the direction of x, take the acceleration. And you're done here. How much is this? D square by 4 matlab, that will be 2k cube by d cube by 2 cube by m is equal to acceleration with a minus sign. That will be minus 16k cube by d cube m into x. This is your omega square. Okay, na? Time period 2 pi root over md cube by 16 kQq. Check. So you just need to find the force. See, here electrostatics got over here. Huh? Once I wrote this, electrostatics got over. It is just vectors after that. I took the net force. Net force is mass into acceleration. A is equal to minus omega square x. Please check. Make sure your cam is blank. I can't see you. Clear with this? Any doubts on this? So here I'll give a homework problem. Try. Same question. What will you do if it is plus q, and this is a plus q and m, and you displace this way by x? Positive charge, huh? Because it will get repelled, it will get pushed back. This will be a homework question. Give it a try. It's a good one. So a negative charge you have to displace along the bisector because they'll attract. See, if you put a negative charge and push this way, what will happen? The plus q will attract more strongly and it will go and stick to it. It will not oscillate. That's an additional question you can try. Let's see one more question, then we will do a little more theory. Let's say we have a pendulum here, mass m, length L. Let's say time period is t1. We have another pendulum here, mass m, charge q, and what you did that you kept a charge q at the point of suspension. Okay, length L. This time period is t2. The third case, same thing, length L, mass m, charge q, but this time the plus q is on the ground. This time period is t3. Compare t1, t2, t3. Meaning t1 greater than t2 greater than t3 less than ऐसा. Is the question clear? Do you remember time period of a simple pendulum formula?
2 pi under root L.
Well, but that is a formula, but I hope you remember how we derived it.
Yes.
Any doubts on this page? This is a good one. Huh? This is a standard problem there. And that homework problem definitely try. Huh? That's a good one. But this is a standard one. Bits and mains, this kind of question repeats. Ritam, done? Try this. I hope the scenario is clear. There is no charge here in the first case. In the second case, there's a charge on the pendulum and the charge q at the point of suspension. Case 3, there's a charge on the pendulum, there's a charge q on the ground. Time periods are t1, t2, t3. I just want to tell me which one is greater, which one is smaller. Try this. It's a good one. When we say conceptual and theoretical question, this is what it means.
Sir, is T1 equal to T2?
Q. Harsh got T3 greater than T1. Reina got T2 is more than T1 and T3. Okay. See the catch, I'll tell you. In the first case, if you go back to the derivation of the pendulum, if you just use 2 by root over L by G, you will get slaughtered. Don't do that. You need to understand a basic idea of what is happening. What is the restoring force here? Mg sin theta, right? So the one who is bringing back to the mean position is who? Mg sin theta. Agree? This is your restoring force. And actually, if you remember the derivation, we did like this thing: mg sin theta into L torque is equal to minus I alpha, and from there we got that stuff actually. Now look at the second case. What happens? Now, when you're displaced by theta, what are the forces acting on this? This is plus q. This is plus q. How is the force? This way, repulsion. And this is mg sin theta. Now you tell me, what is the torque? Will the repulsion force increase any restoring force? No, right? The tension in the string will increase, but the repulsion force will be always along the string. That will never generate restoring force. So electrostatic force is always along the string. It does not generate restoring force. It will never bring you back to the mean position. Therefore, there is no restoring force because there is no restoring torque. So torque due to F is 0. So that means this time period T1 is equal to T2 now. You're getting it. 1 and 2 will have no difference actually. The time period is same because whatever repulsion is there, that is just making the string tight. But C mein there will be a catch. Theta, this is plus Q. This is plus Q. You'll have a force of attraction, right? So here the torque will be more. There is more restoring force. Therefore, it moves faster.
The force of repulsion, right?
Yeah, repulsion, na? So less restoring force. Takes more time. So what is the answer? T3 is greater than T1 equal to T2. Is that clear, everyone? Please check. Ask me if you're confused. The second A and B, right? They're exactly same. Just that gives you illusion that plus Q is repelling, that will move faster. It is repelling, agreed, but the force is this way. That will not create a tangential motion anyways. Is that clear, everyone? Please ask me if you're confused. It's a good one. All clear with this? Let's see one more. So we have two pendulums, length L, length L. This is mass M, charge Q. This is mass M, charge Q. Let this angle be alpha and let this angle be beta. Mass M, charge Q, length L, mass M, but charges 2Q. Alpha dash and beta dash. Okay. Can you compare alpha and beta here to find Compare alpha and beta, two different problems. Meaning alpha is equal to beta, alpha greater than beta, alpha less than beta. Same thing here, alpha equal to beta, alpha less than beta, and this thing.
So first one equal.
This is mass m charge q. This is 2m, 2q. Three different scenarios, people. Compare alpha and beta. Alpha and beta are the half angles, with the vertical. Angles with the vertical. So first case, both are identical. Second case, same mass, but different charge. Third case, different mass, different charge. I hope the question was clear. In each problem, I'm asking who is greater, alpha or beta. So first problem is who is greater. Second problem is who is greater. Third problem is who is greater. So three different questions. See, this is how you learn. You take one simple concept, in that you try to do variations. First one, alpha is equal to beta. I hope everyone got that. That looks obvious. Get the B and C. Try. I'll give you a minute, 2 minutes. Think it's a good one.
So will collision happen?
Collision?
Yeah, when both of them are left.
नहीं. अरे repulsion होगा ना रे. देखो ना, actually what is happening? This plus q are repelling each other, na?
Oh yes,
That
yes,
repulsion is keeping them apart.
yes.
Sir,
I can even ask you to find alpha and beta also. We will do that. Huh, Shaurya?
sir, in second one is also alpha equal to beta.
Okay, but it has more charge, na?
Sir, but the force will, both experiences will be same.
Third one. Try, everyone try. I'll give you a minute, then I'll show you. Shaurya got 2 right.
Sir, in third one, alpha is greater.
Okay, let's see. See, everyone. I can even ask you to find alpha and beta. If this is alpha, if you look at the forces between them, this is the repulsion force. Let's call it L. This is mg. If you take this distance as r, where r is simply 2L L sine alpha plus L sine beta. In this case, but actually the theta and alpha and beta will be same. If you look at the forces, now the forces are identical here. So tan alpha is F by mg, opposite side by adjacent side. This is also alpha. So both are actually equal in the first place. And what is F here? F is K Q square by R square. Now see what happens in the B part. B part was what most people think, right? It has more charge, there will be more repulsion. You're forgetting something. The force is product of the charges. Isn't it? So this is alpha, this is beta. So if you look at the forces, this will be K, Q, 2Q by R square. This also will be same. So it doesn't matter how much charge you have. You can have one charge is 1 and one charge is 1000. Answer will remain same. And this is mg. This is beta. And that will be alpha. Same answer you get. So tan alpha is equal to F by mg. F ka value has changed here. So basically in first two cases, right, alpha is equal to beta. And if you observe here, this tan alpha actually is proportional to 1 by mass, right? It doesn't depend on the repulsion force, it depends on the mass. So more the mass, lesser the angle. So in the third case, if we see now, mass is more on 2m side. So beta will be small. Because the mass is more. Check. So the angles will not depend on the charges, but will depend on the masses. So if you take charge as plus q and if you take this charge as 1000 q, answer will still remain same. Alpha is equal to beta. As long as the masses are equal, it doesn't matter. If the masses change, then the angles will change. Have a look at this. See, simple question, but theoretically you can play around like this. And exam they can ask you find alpha, so you'll find alpha like this. In this case, R will be 12 sine alpha. Check. Any doubts on this? Please ask.
Sir, net force will always be along the string.
Net force. Obviously, नहीं तो tension कैसे cancel करेगा? The tension, F and Ng, all three should cancel each other, no? So F and Ng का resultant should be along the tension. If it is not along the string, it will oscillate. All clear with this? Great. Now let's see what happens actually if you keep the charges in a medium. This is important, a little bit of a theory, so listen carefully. If charges are placed in a medium, what happens then? So this is important. So force ka formula becomes this formula which we wrote now, 1 by 4 pi epsilon medium Q1 Q2 by R square. Now, important thing here, what is this F exactly? This is force on each charge. This is not force between the charges. There's a big difference between the both. What is this? I'll tell you. So when you say this epsilon medium, this is nothing but epsilon R into epsilon naught. Epsilon R is called relative permittivity. So what is the meaning of this? It's also called as dielectric constant. The meaning of this is higher the value of epsilon R, the more difficult for the charges to interact. It's like a resistance. So it is like resistance. And epsilon R ka value is always greater than or equal to 1, and for vacuum it is 1. So what is exactly happening here? Huh? So if you look at the value here, the force in the medium will be 1 by 4 pi epsilon medium, that is epsilon R into epsilon naught Q1 Q2 by R square. This becomes force in vacuum by epsilon R. That means when you take two charges and keep them in a medium, the force on each charge will actually decrease. Are you getting this? Now, can someone tell me why the force is decreasing? when you take two charges and keep them in a medium, why is the force decreasing?
Sir, the particles in the medium are opposing the force of attraction.
देखो क्या हो रहा है ना? Kind of what you said. Let's say if you have charges Q1 and Q2. Now listen carefully. This is the catch. The entire thing is filled with medium. Remember, we just now discussed something. If you put a charge in front of a medium, what happens? You induce charges. These are the induced charges in the medium. Vacuum में ना medium ही नहीं induce करने के लिए. But if you put in a medium, right, this is what happens. We have induced charges in a medium. See now, because of this, what will happen? I want to emphasize on this statement. If you remember this statement here, we wrote force between charges, okay, in vacuum. Here we are writing force on each charge. Both are not same. Now, why is that? I'll tell you. See, listen, imagine we have person A, right, and person B is pushing with 100 newtons. If person C is pushing with 20 newtons, with what force is B pushing A? With what
100.
force is B pushing A? 100, right? I don't care what this guy is doing, right? But if I ask you what is the net force on A?
80.
80. Meaning, same thing hoga dekho. That means the force between Q1 and Q2 na, that will remain same. That will be K, Q1, Q2 by 4 pi epsilon R square. This will be the same force as vacuum. But because of the induced charges, what will happen? It will attract, no? This is the force due to induced charges. Therefore, net force on each charge will decrease, isn't it? Because of the induced charges, they attract, and that's where the net force is decreasing. So this is an important statement there. Force between charges is it does not change with medium. I'll show you how they framed a question on this. Charges is independent of the medium. So most people, what they do now, in a hurry, they're at F by epsilon R. They use this formula. They forget something. This is a force on each charge. This is not force, net force on, this is not the force between the charges. Whereas force on each charge will depend on the medium. So this will be simply Q1, Q2 by 4 pi epsilon R square, which is same as F vacuum. Whereas force on each charge, so Coulomb's law actually gives you force on each charge. This is F vacuum by epsilon R. I hope you're getting the difference. Just think about it. If I ask you, what is the force between Q1 and Q2? Why do I care what is this force, isn't it? But if I ask you what is the net force on charge Q1, then it will matter, right? Net force will matter, but force between them will not matter. I hope that was clear. So see how they'll frame my question. We have two charges, Q1, Q2 in vacuum. Force between them is F. Now charges are placed inside a medium whose epsilon R is 5. So Q1, Q2, you kept them whole thing inside a medium here where epsilon R is 5. So the question, find force between the charges. Find force on each charge. Exam may they'll ask you find force between the charges. Find force on the charge due to the medium. Can you tell me the answers for this? What is the force between the charges?
Q1, Q2 by R square.
F only, na? जो भी initial F था, that only will be there. Nah, this is the force between them in vacuum, right?
Upon 5 for
What is the force on each charge?
F by 5.
By 5. What is the force on each charge due to the medium?
F minus F.
minus F by 5.
F minus F by 5, no?
For F.
Isn't it? See, na, force between them is F. The net force is F by 5. Matlab medium is pulling with 4F by 5, no? Is that making sense? So that is one more thing we can add. The force on charge due to medium is F minus F vacuum by epsilon R. F vacuum is the force between them, and the net force will be this F vacuum by epsilon R. Please check this question. This is important. Force between charges will not depend on the medium. But most people in a hurry, what they do now, force between, they'll write this and come. F by 5, they'll write and come. Answer is F only. It doesn't matter what medium you keep. So force between the charges, force on each charge are totally two different concepts. So please be careful with that. Clear? So this only condition, right? Valid when the entire space is filled with medium. Huh? You have to fill the entire space with medium. Have a look at this. Okay, let's see one more question. Last one for the lecture. We got a square here, plus q, minus q. Let's make it a hexagon. Na? Plus q, plus 2q, plus 3q, plus 4q, plus 5q, and plus 6q. At the center, there's a charge q. Regular hexagon, side A. Find the force on the center charge. I can play like this now. I can make this plus q, minus q, plus 2q, and minus q. It's a plus 3q. Where side A? Let's name these points A, B, C, D. Find the force on B charge due to ACT. Standard is all vectors based. Okay, let's finish. Last one for the day. Today I have a PTM, right? So I'm not going to take any doubts today. And on Friday we don't have a class, huh? Last week I told you, right? So this Friday we don't have a class. So we'll directly catch up next week only. Saturday so we have PTMs lined up. So this week all PTMs only. So next class will be directly on Wednesday. Next week we'll have 3 classes as usual. This week it is only 1. So if your slot is not there on Friday, there's no PTM also. So Saturday so we have PTMs and Sunday also we have. So do have a look at your names and accordingly do attend. I think today is most of you have it today only. Let's get this thing. Let's finish it off. How to do the first one? There's no need to actually, calculate due to everyone. If you can think about a logic there, you can clearly see.
Sir, 5Q and 2Q we can neglect and make it 3Q.
Yeah, isko na, what you can do, can I write like this? This is Q, this is 2Q, this is 3Q. Can I write this as Q and 3Q? This is 2Q and 3Q. This is 3Q and 3Q. 3Q will cancel. 2Q will cancel. This Q and Q will cancel now because opposite charges, they exert same force. So the whole question becomes as if there is a 3Q charge, 3Q charge, and 3Q charge at the center. Is this making sense? Because this Q charge and this Q charge, they will repel each other equally. That will cancel out. This 2Q will repel cancel out. 3Q will cancel out. Only the left out charges are there. They are only exerting the force. I hope that is making sense. And then you're done, right? So this is attracting with force F, this is attracting with force F, and this is attracting with force F. These angles are 60 degrees. So the net resultant will be F plus 2F cos 60. That will be 2F. And what is F? This distance is A, people. F will be KQ small q by A square. That's your answer. In a regular hexagon, the angles are 60 degrees between the thing. Each one is an equilateral triangle. Sure, everyone? You know what is a better question than this? You can try this at home as a homework. We have the clock now. Let's say on each clock you have a charge 12Q, 1Q, 2Q. (3Q) and this thing I didn't draw properly. So at 12 o'clock you keep 12 charge there. At 1 you keep 1 charge. At number 2 you keep 2Q charge, 3Q charge, 4Q charge, 5Q charge, 6Q, 7Q, 8Q, 9Q, 10Q, and 11Q. At the center you have a minus Q. Find the direction of force on minus Q. This will be fun. I don't want the magnitude, direction of force on minus Q. You can try this as a homework.
Sir,
Idea
left,
is same.
left.
Left क्या होता है?
8 o'clock?
नहीं. Try करो, अच्छे से करो. Next class we'll discuss. I hope the hexagon is clear. Square कैसा करना है? Finish it off square.
Sir, direction means in vector form we have.
It will be like, you can say like this thing, no? It is towards 7 o'clock. It is towards 6 o'clock. It is between 6 and 7 o'clock.
10 o'clock?
Tell me like that. चलो solve करो. इतना guess मत करो. Get the B part. Square का answer, people. I will leave it as a homework. It will be there in the notes. You can check it out. You'll have 2 homework problems today. How to do for the square? Square is easy, right? So first I'll do F is equal to K Q square by A square. Okay, I'll keep it simple. That way my life becomes easy. So this is plus Q and minus Q. So these two will attract with a force F. plus q minus q. This will attract with force 2f. 3q minus q. Now be careful here. This distance is a root 2. So this force will be k 3q square by a root 2 whole square. So that force is actually 3f by 2. This angle is 45 and this angle is 45. So f net will be, you can take the resultant components there, minus f plus 3f by 2 cos 45 I cap minus 2f plus 3f by 2 sin 45 j cap. I cap j cap vector components. Put it up. Like I said, once you get the force ka magnitude, it is just a matter of components. Any doubts on this hexagon and the square? So it is just finding the force and then using vectors. You want to do the clock now, okay? Batao clock ka answer kya hai? People are trying and struggling. Ratan says clock ka answer is between 6 and 7. What do others think? Try, I'll give you a minute. People got obsessed with the clock for some reason. So no, when you're so excited, do not stop. Get the answer. Try. I'll give you a minute. At respect to number, you kept that respect to amount of charge. Find the force on the negative charge at the center.
Sir,
Hmm.
it is
बोल रहे हैं sir करके you just stop to tell us something.
sir 45 डिग्री पे है, मतलब 12 o'clock और 9 o'clock से 45 डिग्री पे.
Okay, I don't know what that means, but देखते हैं. Rishi said between 9 and 10, 6 and 10. Okay, let's see.
Sir means like 10 or 11 के बीच में.
See, this is 6 na. This can be written as 6 and 6 na. 1 6 will cancel.
Sir, all will become 6, then 8 and
This is
7
1
will
6. This 2 and this will be 6. But you have to देखो, there's a small catch here, 6. This will cancel, so this is 6. That will cancel 6. So you know how will the charges be? There's a 6q. Six Q, 6q, 6q, 6q. यहाँ पे charge नहीं है. Are you getting it? There is no charge here. So how will the attraction be? This guy and this guy will attract like this. If you see both are equal forces, so bisector will be this way, na?
Sir, this only I told 45 degree, 9 and 10.
ठीक है. He could have given better things. So this and this resultant will be along this line. This and this result also will be along this line. So it is between this line. How much is this? This is between 9 and 10, no? Are you clear with this? हाँ शौर्य. So this is 45 बोल रहे according to you. 45 नहीं है God. ये 30 था. ये 30 था. ये 15 था. That is 75. 45 कहाँ से हुआ? हाँ शौर्य. This is 30. This is 30. This is 15 or this is 15. This you got it right. Check everyone. This is the net force ka direction. This is what I was saying. Simple questions, theoretical. You need to think about it. Okay, so with this, we'll wrap up for the day. So we'll catch up again next Wednesday. This week there's a little scheduled little less classes, but next week so we'll go back as usual. So, but in the meantime, do finish your backlog. Use this time to finish your backlog. I know you have full fluid mechanics, SHM, hey, backlog. Some of you still didn't complete SHM. So do work it out. And HCV, you have only 36 questions in HCV. Finish off for fluid mechanics. So